about implicit differentiation. Okay, maybe at the first and the second and the third meeting we have before, we know that the express for the function is usually y equal to fx, right? But in here we can use the another form, because not only contain x, but it is can contain the another variable. And a function, if we have the y is equal to fx, usually a function in this form is said to be in the explicit form. But how if the equation is contain the another variable, or usually we know that we have the two variable like y and contain x2. So in here we cannot write the equation in the form is y is equal to fx, right? So we say that the x determines y implicitly, and that y is an implicit form or implicit function. So how we can derive an implicit function? Because it is contained another variable, not only one. So we can recall the chain rule for differentiation, or the procedure we use for differentiating implicit function is called the implicit differentiation. So in this capture we will learn about the implicit differentiation. I hope you understand about the explanation. Okay, for the first, the implicit differentiation. First, differentiate both sides of the equation with respect to x. Remember that y is really a function of x, and use the chain rule when differentiating term containing y. So we can differentiate both sides, right? And second is solve the resulting equation for y prime or dy over dx in the term of x and y. Let's see the example. Find dy over dx given the equation y power of 3 minus y squared times x plus x squared minus 1 is equal to 0. So in here we must derive the function and derive the function, because we must derive both sides, okay? And then for the next, we can derive one by one. First, in here derive the y power of 3, derive y squared times x, derive x squared, and derive 1 and derive 0. So in here we can get 3y squared times dy over dx, because first we must derive the y power of 3, as usually 3 times y and power minus by 1, it is 2, and times the derivative of y. The derivative of y usually we can write with y prime, or we can write the dy over dx like this. So in here we can get the derivative of y power of 3. And then for the next, we derive y squared times x, because it is containing two variables, so we can use the product rule, or we can usually use u primes times v plus u times v prime. In here u is y squared, so the derivative of y squared is 2y times the derivative of y, and we can use the dy over dx times x plus y squared times the derivative of x is 1. So we can get this function plus the derivative x from x squared is 2x, and the derivative of 1 is 0, and derivative of 0 is 0. And then we can take the dy over dx in front of the function, so we can get 3y squared in here minus 2yx, and then y squared and 2x in here take another side, so we can get the y squared minus 2x. Because of in this side must or only have dy over dx, so we can get the, or we can take the 3y squared minus 2yx in the another set. So in this function we can get the dy over dx. So it is the last solution. I hope you understand. Okay, let's see the another example. Let's see the equation. The equation is x squared plus y squared is equal to 4 is given. So in here we have the three equation. First, we must know the find dy over dx by implicit differentiation, and B, we must find the slope of the tangent line to the curve at the point square root of 3, 1, and the last equation is find the equation of the tangent line at this point. So let's see the solution of A. We find dy over dx by implicit differentiation. So in here we must differentiating both sides of the equation with respect to x, because in here we must know that dy over dx. So we can derive this function and derive this function too. In here we can get x squared and y squared, and the derivative of 4 is 0. Derivative of x squared, because it is respect to x, so we can get 2x. And then we must derive y squared with respect to x, so we can get 2 in here, y power of 1, because 2 is minus by 1, and times the derivative of y. The derivative of y we can write with y prime, or we can write the dy over dx. It's equal to 0. So because of we must know that in the side only dy over dx, so we can take the 2x in another set and 2y in another set too. So we can get the solution is minus x over y, but we know that y is cannot equal to 0. So this is the dy over dx by implicit differentiation. Let's see solution B. In here the slope of the tangent line to the curve at the point square root of 3, 1 is given by m. M is slope, and we can see that m is equal to dy over dx with the point square root of 3, 1. Because of in the first equation, we get the derivative of dy over dx is equal to minus x over y. So in here we can take the x is equal to square root of 3 and y is equal to 1. So we can get the slope is equal to minus square root of 3. So in here, if we want to find the equation of the tangent line, we can get the slope and we can get the point too. So we use the formula to know the equation of the tangent line. Y minus y1 is equal to m times x minus x1. By using this point and this slope, we can get this function. It is equation of tangent line. So if you want to sketch the graph, you can take and see in here with the equation of the graph from the circle, and for the point in here and the tangent line in here. So it is the answer of the example. Okay, the last example I want to tell you here is find the derivative with respect to x of the implicit function square root of x squared plus y squared plus x squared is equal to 2. In here we must derive 1 by 1 because it is respect to x, so we can get the dy over dx. Y is equal to square root of x squared plus y squared in here, and we can use the power of whole, and plus dy over dx. Y is equal to x squared and d over dx is 2. So we can get the derivative of d over dx from x squared plus y squared power of half is half in here. It's half times the function x squared plus y squared and power of minus, right? Or minus 1 over 2 times the derivative of this function x squared plus y squared, because it is using the chain rule, d over dx from x squared plus y squared plus the derivative of x squared is 2x and derivative of 2 is 0. And we can get this form, half times x squared plus y squared power of minus half and the derivative of this function. Because it is respect to x, well, so we can get the 2x in here plus the derivative of y squared is 2 times y times the derivative of y. The derivative of y is dy over dx, or you can use the y prime, plus 2x is equal to 0. And then we can take 2x plus 2y times dy over dx in here, and 2x and half times x squared plus y squared power of minus half in the another side. So we can get this function. Because of in this side must only dy over dx, so 2x can take the another side, and we can get dy over dx is minus 4x x squared plus y squared power of half minus 2x over 2y over 2y. So we can get this function if we can simplify that. So it is the answer of this example. Okay, maybe that's all. Thank you for your attention. I hope you understand about the explanation. Assalamualaikum warahmatullahi wabarakatuh.